Good day everyone, and welcome to the third video in the series of videos illustrating the characteristics of the tangent function. In the second video, we created a GeoGebra canvas and applet exploring the tangent values in the first quadrant. We added exploration question elements to the applet. In this third video, we will create, illustrate, and visualize the tangent values or the range in the second, third, and fourth quadrants. Do you wonder how to add and visualize the changes of the tangent values in a unit circle and on the tangent function graph simultaneously? If yes, this video lesson is for you. Here are the objectives. Describe how the tangent function behaves across different quadrants of the unit circle. Explain the concept of vertical asymptotes and the periodic nature of the tangent function. Identify key angles and their corresponding tangent values. In this video, we're going to create a spreadsheet. So we are going to develop proficiency in creating and organizing data in a spreadsheet format in GeoGebra. And we're going to utilize spreadsheet task pane to input angles and calculate corresponding tangent values. And we're going to apply formatting techniques to visually represent data points effectively. At the end of this video lesson, each one would be able to appreciate the use of videos for mnemonic devices to aid in remembering facts about the tangent function. Each one would be able to understand how creating and revisiting video content can reinforce learning and facilitate recall. And everyone should be able to develop a positive attitude towards utilizing multimedia tools for educational purposes. Recall that the angles in standard position in first quadrant is positive. And in the fourth quadrant, angle in standard position is negative. Let me demonstrate. The angle BAC in standard position, and for it to be in the first quadrant, it should be positive, right? So look at here. The alpha is in positive value. And in order for us to have an angle in standard position and in the fourth quadrant, it should be a negative angle. So look at here. We need to input a negative angle, such as negative 40 degrees, in order to have angle BAB, for example, in the fourth quadrant, or BAM. So again, in first quadrant, angle in standard position is positive, and in the fourth quadrant, angle in standard position is negative. Now, let's observe some angle measurement changes in the second quadrant. We will add sliders to visualize the angle changes in the second quadrant. So let me demonstrate and please observe. We will reuse an applet with tangent values in the first quadrant. We're going now to add a slider. So we now have angle BAR in the second quadrant. And the slider for the angles in the second quadrant is slider M. So let's have the x-coordinate of point R as object B. And let's have the y coordinate of point R as object W. And let's have the tangent value of angle BAR as object Z. And we say and write Z is equal to W the Y over V the X, because tangent theta is equal to Y over X. Let's edit these two dynamic text boxes here. This one is W and this one is V. And this one is Z. Z or Q. So as the angle measurement moves from 180 degrees to 160 degrees towards 120 degrees and towards 95, and then eventually around 90, what did you notice? Yes, the tangent value is a negative number, and then as it draws closer to 90 degrees, it becomes infinitely small. Look, negative 5,729 something. Are the tangent x values in the second quadrant the opposite of those in the first quadrant? What did you notice? Yes, the tangent values in the second quadrant approach negative infinity as x approaches 90 degrees. And you're correct that the tangent values in the second quadrant are the opposite of those in the first quadrant. Say that in the first quadrant, the range approaches positive infinity, and in the second quadrant, the range approaches negative infinity. I'm going to create a spreadsheet to show that the first quadrant values are the upper part of the tangent curve, and the second quadrant values are the lower part of the tangent curve. We're ready to set up the tangent function visualization. So first, we're going to write function of tangent x in the algebra P. Next, we're going to add a spreadsheet. We're going to add a column angle as the input of the tangent function, the values on the x-axis. So let's now add a spreadsheet. Have angle, column, and we're going to have the tangent x column. We're able to have the x values of the partition B, the values along the x-axis, and column B, we're going to have the y values, the values along the y-axis. We just enter the angles from 0 degrees to 180 degrees, which is 10. So make sure to add a degree, okay, because 10 is different from 10 degrees. So we say 10 degrees. We have 30 degrees. And then here in the second column, we write tangent and then click on a cell along the column A. And then we just need to drag it down like that. Column C will be the points in our Cartesian lane. So we write A2, comma, B2, for example, and then just drag it down. So do the same for all angles up to 180 degrees. Here are the points with the tangent values in the first quadrant, and these are the points with the tangent values in the second quadrant.